In this video, we are going to discuss a problem. These are the previous year university question. So here four resistors are connected in this manner, and they are asked to determine the current that is flowing through from A to B. Okay. So this structure of the circuit, and these four resistors are connected to a voltage source. Let me now discuss about the values of each resistor. Okay. So in order to find the current across any resistance, we can through any resistance we can use Norton's theorem. But here you can see I want to determine the current that is flowing through the straight line. There is no use in applying the Norton's theorem. Okay. So instead of Norton's theorem, if we use mesh analysis itself, we can determine the value of current. So these are the values of the resistor and the voltage source. Okay. So let me explain why there is no use in finding the current using Norton's theorem. Okay. So you know the equivalent circuit of Norton's theorem, right? The current source is connected in parallel with the resistor RTH and the resistance which we need to find, right? So it is nothing but a straight line. So to find RTH, so it is not necessary to find RTH because the entire current ISC will flow through the straight line, right? So it is no use in finding the RTH, but it will be useful for the rest of the problems asked in the similar manner. Okay. So instead of straight line, if I have any resistor, means it will be useful. Okay. So what is the first step to find the RTH means you have to remove the resistance or the pin that is connected across A and B, and you must have only resistors. Therefore, the voltage source that must be short circuited. Okay. So this is how the circuit is. So I am going to rearrange this circuit. I am going to redraw the circuit in such a manner we can find the value of RTH easily. Therefore, you can see it. If I redraw, we can easily find out which two resistors are in parallel. Okay. So for that one, you have to mark the value of A and B, right? So this equivalent circuit can be redrawn like this, right? You can see. So that straight line I'm going to draw here. Okay. After that, these 2 points are A and B, right? So this is my A and this is my B. So I can connect in this manner, right? A and B. So if you see, the 5 ohm and 5 ohm resistance are in parallel, and the 8 and 2 ohm resistance are in parallel, right? So that is the case. I can read 8 into 2 divided by 10 and 5 into 5 divided by 10, right? So I can write like that. So you will get 1.6 and 1 as answer, right? So the overall value will be 2.6, right? So in order to make it simple, I'm drawing like this. Okay. So both are same, right? So I can write 2.6, 2.5 and 1.6, right? 2.5 and 1.6, you will get 4.11. That is your RTH. But there is no use in finding the RTH, I already told you. So next, to find the value of ISC. So now to find the value of ISC, you have to short the terminal between A and B. So this is how the circuit is, right? So we can apply directly a mesh analysis in order to find the current, right? So there is no need in finding the value of Norton's theorem. No need to go for Norton's theorem. So I can take, you can see there are 3 meshes, right? So you have 3 equations, right? So and I have already told you this third loop, and this one is a first loop, this one, and the current direction also you can decide, either it may be a anti-clockwise or clockwise. So I have to write the equation for these 3 meshes, right? So if you see, the I1 direction is in the direction of ISC, and the I2 direction is opposite to that of ISC. So what is ISC value? ISC is nothing but I1 minus I2. Okay. So first mesh 3. So I can write 20, that is equal to total resistance. Total resistance is 10 I3. Okay, the current flowing through the sun is I3, minus 8 is between I3 and I1, so therefore it is minus 8 I1 minus 2 I2, because 2 is between I3 and I2, and both the current are in opposite direction. Okay, so I can rearrange the equation first by I1, I2 and I3. Okay, so next I go for the mesh called mesh 2. Okay, so you can see there is no voltage, so it is 0. Okay, so if I want to find the current, that is 7 I2, right? And there is no current that is flowing through. There is no resistance between I2 and I1, so it is 0, and I3 is minus 2 I3. Okay. For mesh 1, it is 0. Total resistance is 13 I1 minus 0 plus so minus 8 I3. Okay, because I1 direction and I3 direction are in opposite direction. So let me frame the matrix. Okay, so you can write it in whatever manner you want. Okay, so 0, 7, minus 2, and then it is nothing but I1, I2 and I3. That is equal to 0, 0, and it is 20, right? Minus 8, minus 2, and 10. You can write in any manner. Okay, so first we need to find the determinant value. Then you have to find the value of del 1. Then you have to find the value of del 2. So after finding the del 1 and del 2, if you divided the del 1 value by del, you will get value of I1, and del 2 by del, you will get the value of I2. So once if I find the value of I1 and I2, we can find the value of ISC, that is nothing but I1 minus I2. So the determinant value already posted in one video how to easily find the value. So it is nothing but 410. So if I want to find the del 1 value, I have to replace it by that voltage value, right? Okay, that is 0020 from by first column. Okay, so the rest is similar to that of del 1, del. Okay, so this value is nothing but 1120. Likewise, del 2. So in this second column was replaced by 0020. Okay, so the answer is del 2 is nothing but can easily calculate it as using the calculator. So that value is 520. So this is a formula, right? So once if you solve, you will get I1 as equal to, so what is the value of del 1? Del 1 is 1120 divided by 410 and del 2 is 520 divided by 410. So answer is ISC is equal to I1 minus I2. You can see the diagram, right? So the I1 is flowing in this direction, the I2 is in this direction, and ISC is from, you can see the ISC direction and the I1 direction are in the same. So that I am writing ISC is equal to I1 minus I2. So if we solve, we will get the answer for IS. Okay, that is 1.4634. Okay, so you substitute 16434, that is ISC value, that is in Norton sequence. So RTH value is 4.1. So the current flowing through this one is that is IN is equal to 1.4634. So that is why I told you the RTH value is not necessary here. Okay, because the entire ISC will flow through the short circuit. So here the IN and ISC are same. Thank you.